As you can see, the title of this talk is Applied Domain-Driven Design Blueprints for Java EE. Essentially, this is about a project that I run on my own time at Oracle. I believe it fulfills an important gap, and I hope that you will think so as well. If you do not know who I am, my name is Reza Rahman. I am a Java EE evangelist at Oracle Corporation. Up there is my email address as well as my Twitter handle. Feel free to reach out to me anytime during this rest of this conference or any other time with any questions that you like. Always welcome and would love to hear from all of you. In fact, that's one of the reasons, one of the real reasons for coming to conferences such as these in the first place. Okay, so let's talk a bit about what this is all about. Some of you may have heard of this thing called the J2E blueprints or the pet store application. I was actually a big fan of the pet store application back in the day. The pet store, believe it or not, although some people don't realize it, is an extremely important project that has long-lasting effect on our industry. Prior to the pet store or J2E blueprints, you really didn't have much formalized structure for large enterprise applications whatsoever. The J2E blueprints were the very first concept to do that, and it actually has made enterprise development significantly more bearable than it otherwise potentially could have been. In fact, even after more than a decade, the J2E blueprints still continue to be with us. A lot of folks that I talk to even today either use the J2E blueprints as is, or actually, without knowing about it, use many of the constructs in the J2E blueprints. So if you have heard of patterns like data access object, data transfer object, session facade, all of those, believe it or not, actually originated back in the pet store or J2E blueprint days. However, the J2E blueprints are old, right? They are about 10 years old now, and they are not without their problems. Specifically, the J2E blueprints were encumbered by the limitations of the technology at the time, J2E in particular, and also the J2E blueprints were not very good at enabling developers to use proper domain-driven design or proper object orientation or proper object-oriented analysis. If in fact you use the J2E blueprints, it would be hard for you to really stick to the true spirit of object-oriented development. Fortunately though, after so many years, we actually have a very nice alternative, and that alternative is called domain-driven design, or in short, DDD. How many people here have heard of domain-driven design? Okay, excellent. Many of you in this room. So that is very good news. Although you say you've heard of it, in this particular talk, I actually do plan to cover a little bit of what domain-driven design is. I think that's fundamentally important. And it's also important for you to understand what my interpretation of it is in order to really make use of the rest of the material that I will share with you today. Well, as you can imagine, I am a fan of DDD. I've used DDD for about 7 years now in my consulting projects. I believe it's a very, very good architectural paradigm. I actually do think that it is significantly better than the J2E blueprints. And actually, I also think that Java EE is actually a very good technology. In fact, in my opinion, one of the best technologies to implement domain-driven design with. Domain-driven design and Java EE, modern Java EE today, actually have a lot in common, which is why it's a good mix to use DDD and Java EE. So that is where this project that I work on, called Cargo Tracker, steps in. The goal of this project is actually to show you how you can use domain-driven design in a Java EE application. Okay, show you in terms of real code, not simply talk about how you can implement it. So I am essentially attempting to accomplish the same thing that the pet store accomplished years ago with the J2E blueprints in showing you how the J2E blueprints can apply to real working code. Similarly, Essentially, this project does the same using Java EE and domain-driven design. So how many of you here think they have a very good understanding of domain-driven design? Okay, excellent. So this is good. So I can offer something to you, perhaps. So as I said, I've been using domain-driven design for about 7 years. It took me about 3 years to properly understand what domain-driven design is, okay? So what I hope to do in this session is actually help you by sharing my interpretation or my view after 7 years of what domain-driven design really is all about. So we should start by understanding what domain-driven design is at a very high level and why it is important, why it is something that you should care about. The basic concept of domain-driven design is that your application, your code, should look as close to possible as the real-world problem that you are trying to solve. Okay, so there should not be any translation costs. Starting from the screens that you use in your application, to the backend code in the UI layer, to the backend code in the persistent layer, all the way to the database. All of the things that you name, all of the things that you structure should be very closely related to the real-world problem that you are trying to solve. That is the heart of what domain-driven design is. And in fact, that is the heart of what object orientation is all about. If you look back into the roots of object-oriented design, the principal goals of object-oriented design was to enable you to do that, is to write software that makes it look like the real problem that you are trying to solve. Well, that's a nice philosophical thought, but in the end, what is it that you get out of that? Okay, so there's two different very important things that you get out of that. Number one is what's called a ubiquitous language. That means that because you're using the same terminology from your business meeting room all the way down to your database design, nobody actually needs to do any translation. Whenever you say something in the business meeting room, everybody all the way down to the lowest layer of your application will understand what you are talking about. So that means more agility, more faster code churn, and also lesser maintenance costs in the end, because everything is sort of flows in natural language. Everything is structured in a meaningful fashion. And because you are able to do that, you are then able to create complex systems that still make sense, because the real world in the end makes sense. Anything that is close enough to the real world will be automatically more understandable than something that a machine would understand. So when you're doing domain-driven design, what you're really attempting is to humanize the computer. Okay, you are writing a system that is understandable by human beings, not necessarily optimized to the understanding of the machine. Okay. So hopefully that is a good enough introduction to what domain-driven design is and why it is important. Next, in our journey of domain-driven design, it's important to understand what the core principles and, the core constructs and the core architectural design patterns in domain-driven design are. So what I've chosen to do is to explain this using this diagram up here. I really apologize to the folks in the back. I hope that you can read this diagram. If you have to squint, I'm sorry. This is the best I could do given the dimensions of this room. This actually is not a diagram that I created. This is the diagram that you'll find common to almost all domain-driven design literature. If you open up a book on domain-driven design, if you open up a website on domain-driven design, you will see this diagram. And if you have a proper understanding of this diagram, you actually have almost a 60 to 70% understanding of what domain-driven design is. So in the next 15 minutes or so, that is what I will attempt to impart upon you. I want to impart upon you a basic understanding of this diagram. The bubbles that you see here are the core design patterns in domain-driven design And the arrows should demonstrate how these design patterns interrelate with each other in a domain-driven design system. Let's start by examining some of these design patterns. The most important design pattern in domain-driven design is, in fact, the entity. And most of you actually do have a general understanding of what an entity is. In terms of an entity, you should think about a row in a database is a decent representation of what an entity is. More precisely, however, an entity is a thing or a noun in the real world. And in fact, in the real world, a majority of the time you deal with things. A human being is a thing, a stage is a thing, a chair is a thing, a financial record is a thing, a bank is a thing, a customer is a thing. These are all entities. In terms of object-oriented design, an entity is an object, okay, with a unique identity, an ID field in a database record, data that encapsulate the state of the entity, so in Java, properties, fields of some kind. However, also behavior, okay, not simply getters and setter, but behavior that encapsulates the actions that you can perform on that entity. Okay, so that is a very important concept. It's fundamentally different from the way you may have thought of, let's say, a DTO object. Okay, a DTO object simply holds data, whereas a domain-driven design entity holds both data and behavior. All right, and that is the core of what object orientation is really all about. And hence, an entity can take advantage of object orientation techniques like polymorphism, inheritance, encapsulation, and so on. Okay, so an entity is the most important design pattern in a domain-driven design system. Value objects are sisters to what an entity is. The primary difference between an entity and a value object is that a value object does not have an ID of its own. It is not uniquely identifiable. However, otherwise it is very similar to an entity. It is a thing in the real world, it has data, and it has behavior. So you should ask, well, why is this value object thing necessary? Well, in the real world, we do not deal with things that are self-contained and monolithic. In reality, in the real world, things are composed of other things. This desk is composed of a platform, a few levels where I can store things, perhaps a monogram in the front. Okay, these are all embedded objects. This monogram is meaningless on its own, but perhaps this desk has a unique identifier. Perhaps this bit of clothing that I'm wearing is not uniquely identifiable. I am uniquely identifiable, but I am wearing this clothing. The clothing is a value object. I am the entity. Aggregates are again another sister concept to entities. In the real world, in any non-trivial system, you will have many, many entities and many, many value objects. If you were to attempt to model all of these entities and value objects in a single logical model, you would have a very, very complex model. So aggregates help you manage that complexity. And how does it do that? Well, it helps by grouping interrelated entities and value objects together in separate clusters. All right, we will see this hopefully if we get to the example application as to how do you use aggregates. But essentially, these aggregates are groupings of entities and value objects in a given system. In domain-driven design dogma, generally speaking, there is only one entity that is the most important one in a given aggregate, and that is called an aggregate root. Okay, so the general structure of aggregates in domain-driven design looks like there's a root entity, And then there's a bunch of entities that are interrelated to that entity and a whole bunch of value objects interrelated to that root entity. And then there's another aggregate that does the same thing. And these aggregates somehow interconnect with each other in some way in a given system. Okay? Again, it's easiest to explain if you actually take a look at the example code that I hope to possibly get to today. Repositories are essentially structural mechanisms inside of an application. So if you think about a system, inside of a system, entities and value objects live in memory in the application. However, every single application actually also needs a persistent store, because the reality is you have to restart applications. Okay, so when you restart applications, that application state needs to survive the restart. So the way this is generally done is that entities and value objects are saved onto let's say, a relational database. A repository is simply an abstraction that allows you to abstract down that persistence layer code. Okay, so a repository is very much like an interface for CRUD operations. So you take an entity and you say save, update, delete, various flavors of fines and the like, and that is what a repository is. Now, for those of you familiar with data access object or let's say J2E blueprints, this may sound terribly familiar. This may sound very much like, okay, I know this. This is just a DIO object. Well, this is not the DIO object because there's one big fundamental difference between DIOs and repositories. Generally, you have DIOs for every single entity or value object in your system. In this case, you generally will only have one repository per aggregate. Okay, so it's a more complex form of a DIO and with a higher level of abstraction than what a DIO would be. Generally, you perform CRUD operations or repository operations on an aggregate root, and the aggregate root manages the rest of the state within that aggregate cluster. Next thing I want to talk about very briefly is factories. Factories is not something you will run into terribly often. So by and large, creating entities and value objects is relatively simple. You simply create a new constructor, and you add some setters and getter calls, and that's it. That's all you need in order to create an aggregate root or an entity or a value object. However, there are cases where the creation of an entity or creation of an aggregate root is a complex operation on its own right. Perhaps there are some specific recipes that you need to follow. Perhaps you're using the builder pattern to build up the state of an entity or state of an aggregate root. In those cases, you do need another design pattern called a factory. And its primary purpose in life is to help you construct aggregates, construct value objects, construct entities. Lastly, I want to talk about this other last important concept in domain-driven design, or rather design pattern in domain-driven design. Services. Now, when I say services, many of you may be thinking REST-based web services or web services or something of that nature, because that's the parlance that we use, this word service most of the time. That is not the type of service we are talking about here. Okay, that type of service has a place in domain-driven design, and I'll explain what that place is. What this service is, it's called a domain service, and it is part of your core domain model. What makes a service is that it is a special kind of entity, if you want to think about it that way. An entity and a value object is a noun, it is a thing, whereas a service is a verb, it is a do. In all systems, there will be cases where there are important verbs that are just as important as nouns in your system. So, to take an example, in transportation systems, it is the act of actually routing a bit of shipping cargo, let's say. So you have all the information like the cargo information, the shipping information, what route this cargo will take. But the actual allocation of creating the route is called routing, and it's an important verb. Similarly, in insurance, another important verb is underwriting. Okay, so determining how much you can insure a person with. That is a the most important task in insurance, and hence it is a verb, and you need to model it as a peer, okay, as a peer of your value objects and entities. Now, I do want to be cautious in telling you that you should use services or domain services sparingly. Most of your verbs, most of your actions should really be modeled as behaviors of entities. Okay? Services, by and large, are exceptions, and they are not the rule. Okay. Beyond the core concepts of domain-driven design, the design patterns that apply to the domain in modeling the domain, you actually have some other design patterns to learn about as well. And why is this? This is because of a concept called layering or separation of concerns. Let's talk about why this is important for a second. So there are some technologies like Node.js or Rails or some other so-called rapid application development languages that say that you must never create layers. Layers are a bad thing. Well, getting rid of layers can be good for productivity initially. However, I want you to think about the long term of an application that you may have seen. The idea that you shouldn't have layers works well for, let's say, an application that consists of a few hundred lines, a few thousand lines, maybe tens of thousands of lines. However, when you go beyond that, you really need to introduce layers. Okay, so in order to understand why, if you've ever seen a PHP application or a C application in your life, think about that. Those usually have what I lovingly call uber components or super components. Well, what are these? Well, you open up these applications and you'll see files that are thousands of lines long, okay? And you'll see a whole bunch of things that are happening in that file. Well, why are these files so large and complicated? Well, the reason they are so large and complicated is because there's a lot of concerns being tried to be addressed in that same component. So you're dealing with UI concerns. How do I display this to the user? You're dealing with business logic, and you're dealing with database logic all in one place. And it generally turns into spaghetti code. So how do you get around this problem? How do you write systems that scale even if they are 100,000 lines or a million lines large? Well, you need to apply the concept of separations of concerns or layers. And what you do here is that you identify separate concerns in your application and you put them in their own specialized components. And each of those components talk to each other in a layer cake fashion. Well, the nice thing is, in most enterprise applications, we generally know exactly what these layers are. Okay, so these layers are the ones that you see here. The first and foremost is the interface layer. So an interface layer is basically anything external to the system where you receive input and output from. The classical example of this is a graphical user interface or a web page, or your web interface for your application. However, it is far beyond that. So you should also think about interfaces when you are dealing with web services, batch processes, scheduled tasks. If you think about it, these are in fact external input and output to your systems. So they indeed belong also in the interfaces layer. Next level down from the interfaces layer is the application layer. Well, what is this layer about? In very simplistic terms, this may look very similar to the session facade pattern. Okay? An application layer basically describes or models the high-level use cases that a system performs. Okay, so if you look at your business use case document, each of those will model to a method in a service object in your application. The big difference between session facade and the application layer, though, is unlike the session facade, in the application layer components, you will not have any business logic. Okay? All you will be doing is coordinating between repositories, entities, value objects, factories, and the like. Okay? But you will not directly have business logic in the application layer. Again, the best way to understand what this means is unfortunately looking at code. And I was hoping to show you code. If I can't show you code, at least I'll tell you where you can go to take a look at how all of this looks like in code so that it all makes a lot more sense to you. And finally, there is the domain layer. And we've talked about the domain layer, right? So things like entities and value objects and repositories, these all belong in the domain layer. This is the core part of your application, the most important part. This is the heart of your application. And finally, there's the infrastructure. And the infrastructure is basically where a majority of J2E actually comes in. So anything that is not any of these things is infrastructure. Okay? So accessing a database is infrastructure. Getting transactions is infrastructure. Coding for security is infrastructure. These are all infrastructure level concerns. You want to execute something asynchronously, that's infrastructure. Okay? And infrastructure actually, generally speaking, is below the domain layer, but not always. The infrastructure code you can use to implement any of these layers. In fact, you will, in the majority of cases. Okay. So next, I want to talk about how these high-level architectural concepts in domain-driven design apply to Java EE. And as I said, because of the fact that Java EE and domain-driven design have a lot of philosophical things in common, you can actually make direct mappings of domain-driven concepts to Java EE constructs. And this is a high-level diagram of how you could do that. So things in the interface layer will generally be implemented in Java EE using technologies like JSF, or JAX-RS to implement RESTful services, or WebSocket to implement WebSockets, or perhaps JBatch for doing batch processing, or EJB scheduling, or so on and so on. These are all infrastructure level, interface level concerns that map clearly to Java EE APIs. Similarly, EJB is ideal for the application layer. EJBs are in fact designed for creating the equivalent of session facades. So if you look at the application, as I said, they model high-level use cases in your application. So another name for that is a unit of work, right? You're trying to accomplish a specific thing that needs to be accomplished, either fail or succeed in one unit. So that is a perfect place to apply things like monitoring, transactions, security, pooling, thread safety, and the like. Well, guess what? EJB gives you all of those services out of the box. So it's a very, very clean mapping between application components and EJBs. And again, you will see what I mean when you actually take a look at the code, why it's a very elegant fit. Entities, well, they actually have a very good, nice named mapping in Java EE. By and large, entities will map to JPA entities. And JPA entities will let you model both data and behavior as well as IDs. So very, very clean mapping there. Value objects, similarly, very, very cleanly mapped to JPA embeddables. That is the purpose of JPA embeddables. They are very much like JPA entities. The only difference is that embeddables do not have IDs of their own. They're generally embedded within another entity, and that's how it inherits its ID. Majority of Java EE actually is concerned with the infrastructure. Okay, so things like JPA, JMS, JCA, all of these, rest of these APIs are actually in use in the infrastructure layer. In fact, all of the declarative services that are in EJB, you can consider those really infrastructure level services as well. Repositories in general will be mapped through JPA and CDI beans. You do not need EJBs in the repository layer, because the repositories do not need to be transactional. They do not need to be secure. Because remember, at the end of the day, you will not be using naked repositories. Whenever you're going to use repositories, you will be going through the application layer. Okay, so you will get those services from that layer. Okay, so where I would like to point to in the little bit of remaining time that I have is the actual project. Okay, so this is the URL for the project. It's called cargotracker.java.net. If you go to this project, it will basically explain all of what I told you now and much, much more. You can actually go download and set up actual code that implements domain-driven design in Java EE, and you can explore the code by yourself. I've attempted to document how all of this works with Java EE and domain-driven design. So I was going to actually show you a little bit of code and to take about 15 minutes to do that. I won't, obviously, you do not have the time to do that, unfortunately, so I will hope that you will go and check out this application by yourself. If you have any questions, we do have a forum on the website. Please ask questions there or email me if that is what you prefer. Finally, I would like to finish up today by giving you a little bit of resources on how you can learn more about all of this. So I definitely, obviously, recommend the Cargo Tracker Java.net project. I would start there. There is also a very nice ref cards from dzone. If you're not familiar with dzone ref cards, you really should check them out. It's about 3 pages. It's written by a gentleman called Azlaq Khan. And it basically explains all of what I explained in the first part of my presentation. There's also a nice small ebook. It's about 90 pages. It's a very thin book, available from InfoQ. You should also check that out. That will give you a bit more than what the ref card and perhaps my project website will give you. And of course, I always recommend the Aquarium blog. Feel free to take a look at that Aquarium blog. It's a good way of staying up to date with Java EE. So I have 3 minutes more left. So what I'm going to endeavor to do is actually show you a little bit about the website. Okay, so this is the website for the project. There is an overview section, as you can see here. So it will tell you basically all of the information that I talked about right now. After the overview, there are some goals for this project. There's a getting started section where you can go download the zip. Okay, there is instructions for setting up in NetBeans. So you can go ahead and set up all of this project and take a look at how this project looks like. There's screenshots to help you set up the application. There's also the code repository itself, and there's also a Jira issue tracker. So if you run into any issues, you can log them there. And there's a bit of background on all of that we talked about today. And finally, I want to show you the resources section. Okay, so you can take a look at the Subversion code repository. If you don't want to set up the code on your own machine, you can just browse it online. That's available. Of course, the source code zip, setting up in NetBeans, the issue tracker, the mailing list, as I mentioned. So if you run into any issues, you can use the mailing list to ask us questions. And also this particular slide deck that you're seeing and that I showed to you today is also available for download on the website. Okay, thank you very much. Unfortunately, that is all that I have time for today. So, arigatou gozaimasu.